Hello, everyone. Welcome to our first practice of the Math Olympiad training camp. I'm Rina. So glad to see you here, and I will accompany you in the following math journey. So now let's see. The first practice is about the topic of geometry. Let's see the 12 questions together. First, in a diagram, a small square lies inside a large square. The shaded area is 48 square centimeters, and we know the perimeter of the small square is 44 centimeters. So find the perimeter of the large square. Now let's get started with the question. It is easier to figure out the solution if we want to know the perimeter of the big square. So that means first we need to know the side length of the square because the perimeter of the square equals side length times 4. But here, let's see in the question, is there any condition which is related to the large square? Yeah, there is one, the shaded area. But we still need to find another part to solve the area of the big square. Yeah, as you can see, actually, we just need to add up the shaded area and the small squares area. We can solve the big squares area. If we are able to solve the small squares area, we first need to know what is the side length of the small square. Small side length. Actually, in the question, it has already told us the perimeter of the small square. So to solve the small square's side length, we just need to divide the perimeter into 4 equal pieces. So one side is 11 centimeters long. And then to solve the small square's area, we just need to, the area of a square equals the side length times the side length. It is the calculation in the times table, so I thought you can complete it in 1 second. Great, it is 121 square centimeters. Then, to find the big square's area, we just need to add up the shaded part, which is 48 square centimeters, with the small square's area, which is 121 square centimeters. In this way, we can get it is equal to 169 square centimeters. Then let's see. If we know the area of the square, to find the side length, because areas equals side length times side length, and for a square side, the 4 sides are equal length. Then it becomes a question of finding the number times itself equals 169. Actually, we know that 12 times 12 in the times table, it is only equals to 144. So at least we need to try a bigger number, 13 times 13. Now you can calculate on a sheet of paper and share with me what you have got. Great, it is just 169. In this way, we can know that the side of the big square should be 13. But don't jump to any conclusion, because the question wants us to solve its perimeter. So still we need to use the side length times 4 sides to solve its perimeter should be 52 centimeters. So the correct option is D. Did you get it? Hope so. Now let's see the second one. In the rectangle ABCD, point E is on the side AB and point F is on the side AD. The question gives us BE equals 1/3 of AE and DF equals 2/5 of AD. So what is that is the wrong word. It should be ratio of the areas of ABCD and FEBCD. Now, let's see if we want to know the ratio. In other words, we need to solve the relationship between these two parts. So at least, if we don't know what is the specific length, we should use the same thing or the same letter to represent these two parts areas. So first, if we want to make the calculation a bit easier, we had better convert the fraction into ratio. If we know BE equals 1/3 of AE, in other words, we can solve that if BE, the ratio of BE of AE should be 1.3. So here, as you can see, the ratio of BE and AE should be 1 to 3. Now, let's see if BE is considered as one part, then AE should be great. It has 3 parts. Because here we don't know the specific length, so we just use a letter to represent a part. Then, let's see. Because also we know the relationship between DF and AD. We can also convert it into ratio. DF, the ratio of DF and AD should be 2 to 5. Then, because DF and AD, they are in a different side, so we had better use a different letter to represent the part. So DF can be considered as 2 parts, which is 2B, and then AD should be 5 parts. Now we just need to use A and B to represent the area of different parts. The area of the rectangle ABCD should be length times width. So it is AB multiplied by AD. And actually, as you can see, we know BE is 1 part, AE is 3 parts, DF is 2B, while AD is 5B. In this way, we can get AB should be the sum of 3A and 1A, and then multiplied by 5B. So we can get the area of the rectangle ABCD should be 20 AB. Next, if we want to solve the area of the FEBCD, it is an irregular shape. So to solve it, we need to convert it into the difference between two regular shapes. Yeah, I believe you have already seen that. We just need to take away the area of the triangle AEF from the rectangle ABCD. We can get the irregular shapes area. And then to solve the triangle's area, we need to multiply its base by height, which is 3A, and AF can be considered as its height because this is a right angle. So it should be 5B minus 2B, which is going to be 3B. Don't forget, we need to divide it by 2 to solve a triangle's area. So it is 9 over 2AB. In this way, we can get the irregular shape FEBCD's area should be 20AB minus 9 over 2AB. So we can consider 20 as 20 over 1. To make that into equivalent fraction, it will become 40 over 2AB minus 9 over 2AB. So it is 31 over 2AB. Now, because I don't have enough space, so I put the conclusion here. To solve the ratio of ABCD and FEBCD, we just need to use 20AB to 9 over 30, that should be 31 over 2AB. Because both parts have AB, so we can cancel the same parts. Then it will become 20 to 31 over 2. Some students may pick option E directly because you can see in the other options, we don't have such a ratio. But actually, it is not the simplest of all because one of the two numbers is not whole number. So we need to multiply both by the same number. And actually, as you can see, as long as we multiply both we can make that into whole numbers, and it is 42, 31, which is just the option A. So before you jump to any conclusion, had better double check it and think twice. Normally, when we want to use ratio as the answer, we need to make sure both parts are whole numbers. So that's all for the first practice. Hope you can enjoy math and explore math with me every day. See you next time. Bye.